kids, Miss Kulkarni here. As you all know, in chemistry, bonding is extremely important. So in this video, let's find out more information about chemical bonds. So these are important chemical bonds. One of them is ionic bonding. Next is covalent, and the third one is metallic. Ionic bonding forms compounds which we call as ionic compounds. And of course there must be ions which give rise to ionic compounds. And how is it formed? It needs to have transfer or exchange of electrons between the elements. Covalent compounds are like good friends. So they care for each other and they share the electrons. And the compounds which we found with those are covalent compounds. And then finally the metallic bonding. This is between the like atoms of a metal in free state. Now let's find out what is the main important rule behind chemical bonding, and that is Octet Rule. As you see the word octa, that stands for 8, and this is extremely important for any kind of chemical reaction. In fact, every element decides the action in a chemical reaction based upon the Octet Rule. So what is the rule? In periodic table, we have some elements which are called as noble gases. And if you remember, noble gases have octa or 8 electrons which are called as valence electron. Now every element in periodic table is jealous and wants to become a noble gas, or they want to be in royal family. So in doing that, it ends up either losing, gaining, or sharing the electrons. And that is the main reason why we have to study the Octet Rule. And another thing to keep in mind is a bond is simply nothing but attraction between a nucleus which is positive and electrons which are negative. Let's talk about ionic bonding. In ionic bonding, electrons are always exchanged or they are transferred. So that means somebody has to lose and somebody has to gain. And in that, who are the losers? Metals. They are always the losers. They lose the electrons. And who win the contest? Non-metals are the one that win the contest and gain electrons. Let's look at this figure. Here we have sodium and chlorine both in the form of atoms. So there is no charge. In the outermost orbit of sodium, there is 1 electron. Whereas in chlorine, if you count, there are 7 electrons in the outermost orbit. Now as per Octet Rule, they both want to be happy and they want to get to the noble gas state. So what do? Sodium decides to lose the electron and chlorine decides to gain. So when sodium loses the electron, what do we get? We only have 2 orbits for sodium, but now the outermost orbit, which is the second orbit, has 8 electrons. And when chlorine gains that electron, now chlorine also gets 8 electrons. And what do we have? We have sodium as an ion here, that is sodium with positive 1 charge, and over here we have chlorine with negative 1 charge. And these 2 ions come together and we get a bond between them, and that forms sodium chloride, which is an ionic compound. Let's talk about covalent bonding now. As you know, in covalent bonding, electrons are shared. They care and share for each other. But sometimes one element could be more greedy than the other one. So they could be sharing electrons evenly, or sometimes it could be unevenly too. Now let's look at the figure here. This is the diagram for water molecule H2O, where we have 2 hydrogen atoms and 1 oxygen atom. We have 1 hydrogen here with 1 single electron, because that's the atomic number for hydrogen. We have 2 hydrogen atoms, each containing 1 electron, and the red sphere which we have is for oxygen, and the second orbit contains, if you count in the second level, it contains 6 electrons. So hydrogen is the first orbit and it can only contain maximum 2. So if hydrogen wants to become helium, it needs to have 2 electrons. And if oxygen wants to become like noble gas, it needs to have 8 electrons. What do? They decide to share the electrons. So look at this. We have 1 shared pair between hydrogen and oxygen, and this is the second shared pair. With 2 shared pair of electrons, we end up having a compound which is H2O, and it is a covalent compound. Let's turn to metallic bonding. What exactly we mean by metallic bonding? In this case, electrons are loose and actually they live, or you can better use the word float, in the sea. And what does the sea have? Sea has metal ions, and electrons are floating among those metal ions, just like how the fish will be swimming in ocean. Which properties metallic bonding gives to metals? It makes the metals good conductors. It also gives them luster or shining, and also quite high melting point. And we have a couple of examples: sodium, iron, gold, cobalt, and many more. Let's find out what an ionic bonding structure will look like. It will have alternate positive and negative charges. So with that, it forms a rigid lattice, which means the distance between positive and negative ions will be always constant, and electrons are always transferred from one species to other. They are not shared. So many times ionic compounds get crystalline nature, and that is because of this rigid structure. Now, can we predict a compound as ionic compound by just looking at the name or formula? Of course, most of the time we can, because we have 2 parts for ionic compounds. There is a cation or positive ion, and there is an anion, or which is a negative ion. A cation could be a metal or could be ammonium ion, which is NH4 with positive charge, and a non-metal could be the anion. We also can have a polyatomic, something like SO4 -2, versus we can have Cl-1 or Br-1 as an anion. So basically we can have a mix and match combination of all these possibilities. So pretty much if your compound is beginning with a metal, for example if it's CaCl2, that's a metal and that is a non-metal, so you can say that will be an ionic compound. Suppose if we have sodium sulfate, we have the combination of metal and a polyatomic ion. What if we have ammonium and chlorine? We got ammonium ion and chloride ion. Or we can have ammonium sulfate, which is ammonium and a polyatomic ion there. So pretty much by just looking at the name or compound formula, we can predict if it is an ionic compound. There is one more method by which you can predict if the compound is ionic or not. Let's find out what is that trick. So the second trick is calculations for electronegativity. And there's an electronegativity chart here. Every element has different values. Electronegativity is how much an atom likes the electron. So that means how much pull it has to exert to gain an electron. Now we are going to use the values from the table, and there is delta En, which means the difference between electronegativity. And if that difference is 1.7 or greater, then that means the bond is 50% or more ionic bond. Now let's find out if the rule for electronegativity is going to qualify these compounds with ionic bonds or not. The first compound is NaCl. We have a bond between Na and Cl, and the values for both Na and Cl are 3.0 and 0.9 using this electronegativity chart. So when we subtract these two values, we end up getting 2.1 as delta En. Delta En more than 1.7 will qualify this to be an ionic bond. So if we do the same calculations for remaining bonds in these compounds, what information we get? For aluminum bromide, a bond between aluminum and bromine ion will have delta En equals to 1.3. Then for beryllium iodide, it is 1.0, and between copper and chlorine, it is 1.1. Of course, keep in mind, this is a prediction if the bond is more than 50% ionic or not. We also use other theories and other rules. So I hope you guys enjoyed the video. I will see you again in next video. Until then, bye bye.